Once again, Gemini 11's problems started when Dick Gordon had his chance to do a spacewalk. Actually, the problems got started even before they opened the hatch. They had some problems with some of their equipment. They found that Gordon got tired from just assembling the gear for his spacewalk and sitting in a pressurized spacesuit in the cabin of Gemini 11 before they even opened the hatch. By the time he got out, he was already tired. One of his main tasks was to straddle the nose of the Gemini, as you see here, and attach a tether that would unfurl from the Gemini to the Agena so that they can conduct some experiments in what is called a gravity gradient maneuvering, which we'll see a little later. But that exercise of just attaching the tether onto the nose of the Agena got Gordon so overheated and so tired that he was blinded by his own perspiration in 0G and was so exhausted that he decided to come back to the cabin and cut the spacewalk short. Pete Conrad was very concerned. The commander, Pete Conrad, was very worried that Gordon might get so tired that he wouldn't even be able to get his way back inside. So he readily concurred that it was time to end the spacewalk. And the whole episode just kind of underscored the continuing difficulty that NASA was having with spacewalking. A little later in the flight, one of the most spectacular parts of Gemini 11, they used the Agena's engine to reach a new altitude record of 850 miles. And from the high point of that elliptical orbit, they could look down on, as Conrad described it, the whole southern portion of the world. And of course, the curvature of the Earth was readily apparent and beautiful colors and detail. And so that was one of the more successful aspects of the flight. Actually, most of the flight was quite successful. Even the gravity gradient experiment, which they did later, after undocking, they let that tether unfurl. And at first it was a little frustrating to Conrad because he was trying to use the Gemini's thrusters to get the tether to stay taut and then start the two spinning around their common center of gravity. But that didn't go so well. It was, Conrad said, it was almost like the tether was doing like a skip rope between them. But eventually they just were advised by Mission Control to just let it sit there and find its own level, so to speak, as they orbited the Earth, and the tether eventually straightened out. And indeed, they were able to generate, by a very slow rotation around that common center of gravity, they were able to create a very slight amount of artificial gravity, which was the point of the experiment. Gemini 12, the final mission in the Gemini project, was to fly in November of 1966, and the most important objective of the flight, even over and above the usual rendezvous and docking exercises, was to finally tame the troubles that NASA had been having with extravehicular activity, or EVA, otherwise known as spacewalking. And so Buzz Aldrin, the responsibility kind of fell on Buzz Aldrin, who was the co-pilot and the spacewalking crew member of the flight, along with his commander was veteran Jim Lovell. Aldrin was very intent on carrying out his spacewalking without getting overtaxed and without getting behind the curve in terms of energy and being able to accomplish all his objectives successfully. So what he did, he and some others at NASA came up with a plan to practice underwater, which would simulate the weightlessness of being in space. And NASA actually rented a swimming pool in Baltimore at a school, and they put a Gemini mock-up and an Agena mock-up at the bottom. And Aldrin got into his spacesuit and did a number of run-throughs, and he also benefited from having new foot restraints to anchor his body so that he wouldn't have to struggle to maintain his position as he performed various tasks. And he developed ways of working that were deliberate and methodical and didn't rush. And you'll see here in this film, here's Aldrin in the pool practicing some of the maneuvers he would do. There were also a number of tests in the back end of the Gemini where he would undo bolts and so forth. Here's Aldrin in space on the flight and carrying out his tests in 0G in a vacuum. And now he's moving on a handrail, a special handrail, over to the Agena, which is a very easy matter to do. Doesn't take a lot of effort, just hand over hand. And now he's anchored at his work site with some tethers that restrain his body, and he's able to do everything on his agenda without getting tired out, and it ended up being a complete success. And that brought the Gemini program to a successful, if I can get to the next slide here, there is Lovell and Aldrin on the aircraft carrier WASP, and this was the successful conclusion of the Gemini program. NASA rightfully felt a great sense of achievement and a great sense of excitement and optimism about moving on to Apollo, and that, in fact, was what would come next. The first manned Apollo mission was originally, they had hoped to have to fly it in the end of 1966, maybe even in a joint mission with Gemini 12, but they didn't get it ready in time. And so the mission was scheduled for February of 1967. And the crew you see there, veteran Gus Grissom and Ed White, of course, the veteran Gemini 4 spacewalker, and rookie Roger Chaffee from the third group of astronauts. And their flight, Apollo 1, was to be a 2-week test flight of the early version of the Apollo command module and service module. And we'll find out more about the details of those modules, but for now you just need to know that it was called the Block 1, which was the version that was not intended to go to the moon. It was intended for Earth orbit tests. And they would be launched on a Saturn 1B booster, and that was what NASA was looking forward to as Gemini came to an end.